Hi, I am Thandi Khosa, a finalist in the National Teachers Award for Mathematics. Throughout my years of teaching and marking matrics nationally, I have realized that mathematics learners are not performing well in certain topics. These topics are Euclidean geometry and trigonometric for paper 2, and for paper 1 is function and calculus. These will be the topics I will be covering in these revision videos. Okay folks, it's Khosa Thandi. Again, we are now doing calculus. It is one of the important topic which contain more marks in your examination, plus or minus 50. So you guys need to master this topic so that you can go there and take free marks and then get passing well and distinctions as well if you can. Now, with the calculus, we have extracted different questions from different question papers as well. So now what we are going to do now is to try and see what is it that is hindered here, which makes us not understand this topic sometimes. So we have different questions to do that. Okay, let's look at the first one here. It's in question 8. Usually calculus comes in question 8, and if you are lucky, it will be in question 7. But it's question 8 and question 9, and sometimes question 10, depending on the examination. Now, in question 8 now, for calculus, we are given an equation. So let's start. This is our question 8, and it's still in paper 1. Remember, about plus or minus 50% or 50 marks out of 150 that you will get. Okay, the equation that we are given is f of x is equals to 2x to the exponent 3 minus 5x squared plus 4x. What a nice question. I like this one. Now, 8.1 says, calculate the coordinates of the turning point of the graph of f. Folks, remember, when we want the turning point, we have to do the first derivative, and after that we must equate it to 0, because we are talking about the turning point whereby we are talking about the straight line that will touch there, and it will have the first derivative or the gradient as 0. Now the first derivative is what we are looking for, which is our gradient. Folks, the first derivative, you must write this small one or prime at the top of f, and then when you derive, remember, you will have to take the exponent, multiply the coefficient with it, and then subtract 1 at the exponent. So it's going to be 2 multiplied by 3, which will give us a 6, and we'll have x, and in the exponent we have 3 minus 1, which will be 2. Continuously, we put the minus there. We'll have 2 multiplied by 5, which will be 10, and then x, on the exponent we say 2 minus 1, which is 1. For 4x, we are going to say, remember, each and every thing has the power of 1. A number, a variable, has the power of 1. So it means that this x has the power of 1. In other words, we're going to say 4 multiplied by 1, for which it will give us a positive 4. And then we will say minus 1 at the powers, for which then it will give us 0. X to the power 0 is equals to a 1. So in conclusion, when you are calculating the coordinate, you will have to let your f first derivative to be equals to 0. As I said at the beginning, this is your gradient. If that is 0, then it means you have 6x squared minus 10x plus 4 equals 0. And then to see if it's factorizable, you can actually try to divide everything by 2. Then you remain with 3x squared. To simplify it, 3x squared minus 5x plus 2 equals to 0. And then we factorize. We'll have 3x minus 1 and x minus 2. Remember, at the end of the day, when you remove the bracket, multiply back, you must get this statement as it is. So it is like that, such that we'll be able to get the negative 5. This is just algebra. Therefore, x will be equals to okay, let's see. I think we've made a mistake, because if we multiply this back, let's do this. 3 multiplied by 1 will give us 3x squared. That is correct. A 3 multiplied by 2 will give us a negative 6, and that would make us have a mistake. So it means the 2 must be there with 3x minus 2, and the x must have a minus 1. So it's 3x minus 2, and it's x minus 1. Okay, so let's multiply again, check if that is true. 3x multiplied by x give us 3x squared. 3x multiplied by 1 will give us a negative 3x, and a negative 2 times x will give us a negative 2x, for which a negative 3x minus 2x will give us 5x. Perfect. So now we are in the good direction. So this means we have x equals 1, or x will be equals to 2 divided by 3. Those will be your x coordinates at the turning points. Folks, remember the x coordinates does not give you the full turning points. So you need to use them together with the original equation to find the y value. So we are going to start with the x being equals 1, and then we will do the x equals 2 over 3. Okay, for x equals 1, f of 1, it's equals to 2 multiplied by 1 to the power 3 minus 5 times 1 squared plus 4 times 1. You must be careful and make sure that you go back to the original equation to substitute in order for you to find the y value. And that is 2 minus 5 plus 4, which gives us 1. It is 2 minus 4 plus 5, which will give us a positive 1. So it means one of the coordinates, therefore, will be 1 and 1. Now, for x is equals to 2 over 3, it means we are going to substitute that same original equation, which is this one. Wherever we see x, we are going to put 3 over 2. So it is f of 3 over 2. It's going to be equals to 2 multiplied by 3 over 2 cubed minus 5 into 2 divided by 3. 2 divided by 3 squared plus, let's write it here, plus 4 into 2 divided by 3. So this is where we are using x is equals to 2 divided by 3. And to get it right and not get confused, you can go to your calculator, punch it as it is. So you have 2 multiplied by 2 divided by 3 all squared, all cubed. Okay, let's do the calculator and then get to the answer. It's minus 5 with a fraction pattern with 2 divided by 3 all squared. Remember, we have to substitute it on the original equation for us to find the y value, not on the derived equation. Always we substitute on the original equation, for which it's giving us 28 divided by 27. Now this is our second coordinate with 2 over 3 and 28 divided by 27. And that's the solution. It's 5 marks, folks, and this 5 marks should be thoroughly done, clear, so that you can be able to get it full. So that's how you could have answered the question. They said calculate the coordinate of the turning point of the graph, and it's fully 5 marks. Okay, let's check question 8.2. In 8.2, they said prove that the equation 2x cubed minus 5x squared plus 4x equals 0 has only one real root. People, in this one you have to do factorization direct. But if you look at this one, each and every term contains x. So it means we can be able to take out the common factor of x and then remain with a quadratic. So let's take out the common factor as x. We're left with 2x squared minus 5x plus 4. If we look at the equation inside the bracket, putting it on the equation, quadratic equation, x is equals to minus b plus minus the square root of b squared minus 4ac divided by 2a. We can see that the discriminant is going to give us a negative answer. So because of that, it means we cannot say that that's an answer. So let's check. This is what I'm saying. If you do the discriminant, you will see what is going to come. Remember, the discriminant is equals to b squared minus 4ac. And this is the inside part of that equation. Okay, your b there is minus 5, so it's minus 5 squared. Minus 4 times a is 2 and c is 4. When you simplify it, you will get a negative answer. So it's negative 7. Now, if you have negative square root in this curriculum and your syllabus says you don't have a negative answer, so it means that everything that is inside this has no solution. The only real solution you have, therefore, is x is equals to 0. After you have done that, you will see that there is no real solution of the other part. There's only one. You can see only one is the solution, and the bracket does not have any real solution. So yes, you have proven that there's only one real solution. Okay, so you can conclude, therefore, the equation of f of x has only one solution. Okay, and that's it. Okay, matrix, we are continuing with the question 8. So let's check what the next question says. Probably when they ask you to find the turning point and also to find the x-intercept, if there's possible of them, you will have to draw the graph next, because they just had unpack it so that you can have a direction. Now, 8.3 requests you to sketch the graph of f, and they want you to show those intercept and the turning point. Now, remember, on 8.1 and 8.2, you have found the turning points. So this is one of the turning point, and this is the second one. And also in 8.2, you have proven that there's only one x-intercept, and the others are not real values. So because of that, it means now we can go straight to the drawing the graph. Now when we draw the graph, we have to try and make our Cartesian plane. At least that's where we start. So let's do the Cartesian plane, and then we shall take it from there. This is our Cartesian plane, and we'll have to label it our x-axis and our y-axis. Now, there's nothing much we need. The only thing that we need now is the x-intercept, which is there. And then also we need the turning point. So let's suppose that this is my 1 here. It means that the 1 will be at my other turning point part. So I'm going to just put this dot so that I can be able to go up. And for x, it is 2 over 2 divided by 3. Remember, 2 divided by 3 is actually less than 1. So it is somewhere there below 1. So this is my other turning point. So I'm just going to put another line there. They are likely all on the first quadrant. And then we have 28 divided by 27. That is just a little bit above 1. So if this is 1 for the other points from y to get to my turning point, then the other point can be there, which is the 1 for, this is 1, this is 2 over 3, this is 1, this is my 28 over 27. And then from there, remember I had 0 here for the x-intercept. So it means I can now draw my graph From the turning point, it's gonna be like this, and it goes up, and it's going to be like that. It has to touch there. It's not really up to scale, but this is a shape that you'll expect. It starts from below the third quadrant, going to the first quadrant 10, with the turning point of 2/3 and 28 divided by 27, and the other one is 1 and 1. This is our graph of F. So can you see how smooth your graph should look like? And you must label it, as they said, you must label it. Okay, it is just 3 marks. 8.4, they are asking you this question and they want you to be able to answer it. It is 3 marks as well. 8.4, they said, for which values of x will the graph of f be concave up? Now, talking of concave up symbol means greater than 0. So it means concave up, you should put that in mind. Concave up, concaving up, it simply means the second derivative, it's going to be greater than 0. Okay, so let's do the second derivative. Remember your first derivative you did in 8.1, it was 6x squared minus 10x plus 4. So that's what we are going to use now to continue with your work. So this is what you have to remember now. It's the first derivative, let's copy it down. It's equals to 6x squared minus 10x plus 4. Now the second derivative will be equals to 12x minus 10. That is your second derivative. But we are saying that for concave up, our second derivative must be greater than 0. So we are going to take the 12x minus 10 and make it being greater than 0, because that is our second derivative. And we can start doing algebra. There is 12x is greater than 10. Divide both sides by 12. So x is greater than 10 divided by 12, which can be simplified and be written as 5 divided by 6. So it means that for the value of x, whereby the graph of f is concaving up, x will be greater than 5 divided by 6. And that is the end of this question. I guess this is clear.